Good morning, everyone. I'm Helen WONG, and I am an architect from Architectural Service Department. First, I would like to thank Autodesk for giving these opportunities and for us to present our project. Today, I would like to present our project, the signature project scheme at Eastern District. It is the Eastern District Cultural Square. Before going into the project, I would like to give a brief introduction to our department, the Architectural Services Department. It is a department under the Hong Kong's SAR government. It performs the following three core functions in relation to government-owned and government-funded facilities. The first one is the monitoring and advisory services. The second one is the facilities upkeeping and then the facilities development. Okay, the aim for this project is to provide an outdoor performance stage for 1,000 audience. And we have to also provide the shelter for the stage, ancillary facilities, lighting, and power out source for audio systems. Also, we have to carry an acoustic impact study for the Director of Environmental Protection Department to approve. Let's look at some of the examples of outdoor theaters in Hong Kong. In Hong Kong, due to the high density in land use, we rarely find any outdoor theater. So the people just performed on the open area, and sometimes the outdoor theaters are not acoustic effective enough and creates nuisance to the surroundings. And many of the times, the outdoor theaters is too close to the noise-sensitive receivers and creates nuisance to the neighborhoods. And does this apply to our site? Our site is at Southgate 1. It is approximately 200 meters from the Southgate 1 MTR station. It is adjacent to Average Bay Promenade, Tam Kong Temple, and Tam Kong Road, and Southgate 1 Typhoon Shelter. The site area is 4,740 square meters, and the amphitheater area is 225 square meters. Yes, it is below 230 square meters, and no sprinkler is required. Take a look of our surroundings. It is surrounded by schools, temples, and residential buildings. And the noise-sensitive receivers are found very close to the performance stage. The closest noise-sensitive receiver is as close as 50 meters away. It is really close. The shelter of the stage must be able to block the noise very effectively in order to meet the requirements from EPD. So the challenge for our project team is to optimize the shelter design. Our project team is employing BIM to optimize the shelter design in order to design an effective noise barrier for neighborhood and good sound quality performance stage for the audience. And of course, we have to ensure the structure is buildable. And the aim for accurate tender price is very important for our project because we only have very tight budget. So we have to ensure the projects have to be completed within the tight budget. First, our acoustic consultant used BIM models to test the impact of different kinds of music based on the background sound generated and they test in the site. In order to design effective noise barrier, we have to note the sound level of the site first. And after testing, we found out that after testing with different types of music related to the site, we found that pop music, jazz music, and Chinese opera are okay for performance in the site. However, there will be no rock music. And for the sound and forms, acoustic consultants and also test different forms, such as with walls to serve as noise barrier. Different heights of walls are tested in the computer. And architects, structural engineers, and QS all work together on the sound performance test and the forms. And then acoustic consultants will test the forms again. And this collaboration went through several times until we get the final forms of the shelter. By combining noise barriers of different heights and roof designs, the most effective noise barrier performance was achieved, and steel structure was adapted to minimize the building bulks. The form of the amphitheater is irregular, so the geometry of the structural steel member and the aluminum panels of the cladding systems are irregular too. Hence, a wide range of member size and connection details are incorporated into the design. This is a challenge to our team because it cannot be presented in the traditional 2D drawings. And in normal 2D drawings, if we draw this in our traditional 2D drawings, we need a lot of technical skill and, most important, a lot of imagination. So BIM was used as a tool for designing this shelter. The shelter, it comprises of 3 layers. The middle layers is the functional layer. It is the most important layers of this shelter. The acoustic aluminum cladding system acts as an acoustic barrier and a waterproof layer, and the layers forms a continuous surface to protect the stage. And then the second layer is the inner layer. This is a layer for sound absorption and reflective layers. So in BIM, we tested these layers with different angles and test so that it will perform a good performance and good qualities for the performance. And this layers is made of aluminum perforated sheets. And the last layers is the outer layers. This is a layers for sun shading layers, and it is also made of aluminum perforated sheets. And different elements from different planes, determining the elements, lengths, angles, and how they are fixed into each other could not be done in 2D drawings. With BIM, now we show the real situation of how they join together, and then sometimes we can even explode views of certain elements so that we can know clearer or to communicate clearer. And then for structure, the complicated steel system can only be presented in 3D format of BIM, which shows the actual build-up of the design and connections in details. During the design stage, when the design structure members and aluminum panels were integrated in BIM environment, the sizes of certain structural members were found too slim to anchor the aluminum panels attached to them. So the design team corrected the sizes and verified the connection. This is very important to our project because we have limited time and limited budget. So to resolve the problems in early stage, which can reduce the time and the cost implications in the construction stage. And for the cost, as I mentioned many times, our budget is very tight. Therefore, accurate cost estimation is very important. The panels are tilted, so there's no way to determine the sizes and cost in the 2D drawings. So how are we going to cost it to make an accurate cost estimation? We use BIM and Dynamo to allow all the accurate specification of sizes and cost. We list all the members of the steel members and all the panel sizes, so to allow accurate costing. Also, we use BIM to test whether more normal size panels can be fit into the design. And eventually, we can standardize 30% of the panels. And also for constructability, BIM enables easy and repeated simulations of construction process in the VR environment. Hence, the design can be refined to achieve optimum solutions on standardizing of members through this simulation process. Constructability of the design is improved and the cost is toned down. With 3D models, communications with our users, contractors, suppliers, and operators and all other disciplines were so much easier. It's much easier to explain to different disciplines that how the 3 layers of the shelters are functioned. Now, I would like to present a video to show more details of our project.
Signature Project Scheme at Eastern District Cultural Square. This project is a signature project proposed in the Eastern District. An outdoor performance stage for 1,000 audiences with canopies, integrated ancillary facilities and lighting, as well as power input for audio systems. The target is to design for an effective shelter for the outdoor amphitheater, to achieve high quality sound performance and as a noise barrier to the NSRs in the neighborhood. BIM is used for sketch design stage, detail design stage, and tender preparation stage. Noise-sensitive receivers are found very close to the amphitheater. BIM acts as a guide for the project team to select the types of music suitable for this cultural square. An acoustic consultant tested for sound distribution mapping for different building forms. The architect and the structural engineer revised the building forms according to sound distribution mapping. Instead of designing a large, thick, tall and amphitheater, the project team aimed for an effective noise barrier with enhanced visual impact to the surroundings. It helped the project team to specify the material requirements in the tenders. Different layers of claddings were demonstrated three-dimensionally in tender drawings. Structural tender drawings and statutory drawings are prepared by Revit. BIM allows for collaboration between disciplines at early stages. Project team used Revit to resolve structural detail connections at an early stage. Details of connections were listed in the tender documents to enhance communication. Utilizing Dynamo in Revit, all panel sizes are listed for precise cost estimation. Approximately 30% of panels are standardized. All structural member sizes are listed for precise cost estimation. Early testing on cladding systems allow for early resolving of construction problems.
Though BIM is a unique tool for analyzing the building forms and acoustic performance, it allows better communications and its accuracy in costing. And most importantly, the problems were realized and resolved at the early stage. And the conclusion, BIM as a tool for designing an effective noise barrier and good sound performance for outdoor amphitheater, to collaborating multidisciplines, enhance current practice with BIM technology in enhancing visualized experience and compunction. We have used BIM to work out these wonderful results, and so HKSAR will continue to develop in-house expertise on BIM in incremental manner. We shall continue to encourage stakeholders in the industry to adopt BIM on the project-based level appropriately. Thank you very much.